to undergo the glycolytic pathway. So first function of insulin allows the glycolytic pathway, glycolysis in the liver. Secondly, AKT also triggers glucose to produce glycogen. Wow, this is beautiful. Insulin is so powerful. It's so beautiful to have insulin in the body. Apart from stimulating the glycolytic pathway, it also stimulates glucose to undergo this synthesis that produces glycogen, and this process is called glycogenesis. Wow, this is beautiful. This is really beautiful. This is the first function the insulin does on the liver. So it brings, when glucose comes in, it attaches itself to tyrosine kinase receptor, which allows the production of an intermediate that is able to change glucose to glycogen and also glucose to pyruvate through the glycolytic pathway and the glycogenesis pathway, glycogenesis. Okay, now this is what it does in the liver. Now let's see what it does in the muscle. Now this is my diagram of the muscle. It looks like a chicken, but please, let's just use this. Okay, on the body of the muscle, we have some GLUT transporter. I know you're tired of this, but please, you have to pay attention to these different types of, we have GLUT1, GLUT2, GLUT3, and even GLUT4 transporters. You have to know their difference. I'm going to do a video on receptors and transporters also, so that you get to have a picture of these different types of transporters and also receptors. So on the body, let's just focus on this. On the body of the muscle, you have not GLUT2, but GLUT4. That is glucose transporter type 4 transporter. GLUT4 transporter are dependent on insulin. That is the difference. GLUT2 transporters are not independent. They do not need insulin to be activated. But for a GLUT4 transporter to be activated, it is dependent on insulin. So this is what insulin does. Do not forget, the stimulus is hyperglycemia. Glucose is so much in the body. It's so much. So insulin is trying to regulate the blood sugar to become normal, which is 80 to 120 milligram per dl. So this is what insulin does. Insulin comes here. I'm going to represent insulin as I told you. It binds to these receptors, the same thing, tyrosine kinase receptor. It binds and it produces this intermediate also, PI3K and AKT, protein kinase B. When it stimulates this particular pathway, protein kinase B stimulates GLUT4 to allow the entrance of glucose. Beautiful. That is the first thing insulin does. It stimulates tyrosine kinase receptor to allow GLUT4 receptors, to allow GLUT4 receptors to allow the intake of glucose into the muscle. So the first thing the liver does, this is the first thing, insulin is beautiful, the muscle does. Number one, it allows glucose uptake. Please, I would love you to just jot this down. Glucose uptake. The first thing it does, it allows GLUT4 transporter to be free by allowing glucose to come into the muscle cell. That's the first thing. So when it does this, glucose is now in the cell. Glucose is now inside the muscle, It's now inside the muscle. It stimulates. So when glucose becomes pyruvate, it becomes acetyl-CoA, you know, all this stuff. Then it goes into the Krebs cycle, citric acid cycle, it goes into the citric acid cycle, and probably it is due different modification. It is taken to the electron transport chain through oxidative phosphorylation, and it becomes ATP. We all know that. So it stimulates this pathway also, glycolytic pathway. This is beautiful. insulin is very, very important in the body. Very, very important in the body. Apart from glucose uptake, it also stimulates the pathway glycolysis. I am so happy that I'm doing this video. I hope you understand where I am coming from and where I'm going to, and I do not forget to like, subscribe, and also make comments on how we can improve our video. Please take these key points. They are very, very important. That is not the only thing insulin does. You see this blue transporter here? Do you see this blue transporter here? Okay, on the body of the muscle, because the muscle loves protein. It needs protein to function well. It really needs protein to function well. When you're in the fed state, that means you ate in the fed state. When you're in the fed state, you know, we have a lot of proteins, and also there's a lot of proteins in the bloodstream. So the subunit of protein, the smallest unit of protein, is amino acid. This is what the body would want. So this transporter here is this receptor here, yeah, it's an amino acid transporter. It's an amino acid transporter. So it allows the entrance of amino acid. So when insulin, this is it, when insulin attaches itself to the tyrosine kinase receptor that produces this intermediate, it stimulates this receptor, the amino acid receptor, to allow amino acid to come into the muscle. So it yanks off amino acid from the bloodstream, because you're on the fed state, so you have a lot of proteins. In the body. So the subunit of proteins, the backbone, the smaller subunit of protein is amino acid. So it yanks off the amino acid and brings it into the cell. What now happens? This is so beautiful. Like, I'm really excited. What now happens when amino acids are in the cell, in the muscle, when they come into the muscle? So I'm going to represent my amino acids. So this is what happens. Oh my God, this is what happens. It allows protein synthesis. It binds different subunits of amino acids and makes a protein. Insulin is so powerful. So what does it do again? The first one we said glycolysis. The second one we said amino acid uptake. It allows amino acid uptake. And the third now we have protein synthesis. Protein synthesis. Are we there? It allows amino acid uptake. It also allows the entrance of amino acid into the muscle and makes protein synthesis. It also uses up the glucose that comes inside the muscle cell and allows it to undergo the glycolytic pathway from glucose to pyruvate. Insulin is very, very, very beautiful and very useful in the body. By stimulating the TKR, the tyrosine kinase receptors that produces this intermediate, which stimulates GLUT4 transporter to allow glucose. It also allows glucose uptake. Wow, because it allows glucose to come into the GLUT4 receptors, because GLUT4 receptors are dependent on insulin. So insulin has to trigger this receptor to allow GLUT4 to allow the entrance of glucose into the cell. So this is very, 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 very beautiful. Glucose uptake, we have glycolysis, we have amino acid uptake, we have protein synthesis. Beautiful. That is not the only thing insulin does. Insulin also allows the conversion of glucose to glycogen. It also allows the conversion of glucose to glycogen. Which process is that called? Glycogenesis. Excuse me.